Hello everyone, my name is Nurin Kamaliya binti Shamsul Kamar and my metric number is 200441. For today, I'm going to teach you about arithmetic and logic instructions that you can find in microprocessor and microcomputer. Without further ado, let's start. So today, we're going to take a look at two different topics. The first one is code assembly language unsigned arithmetic instructions that include addition and subtraction. The second one, we will look into code assembly language logic instructions that include AND, OR, and XOR, shift right and shift left. And the last one, we're gonna do a few exercises to help you understand about the instructions. Code assembly language unsigned arithmetic instructions. Actually, there are few arithmetic instructions, which are ADC and SBB. But for today, I'm going to cover addition and subtraction only. Addition of unsigned numbers. The form of the add instruction is add destination, comma, source, semicolon, destination equals to destination plus source. Add and ADC are used to add two operands. The destination operand are used to add two operands. The source operand can be a register in memory or immediate. Memory-to-memory operations are never allowed in x86 assembly language. The instruction could change zero flag, sign flag, auxiliary flag, carry flag, or parity bits of the flag register. For example, show how the flag register is affected by. They give you move AL 0F5H and add AL 0BH. So the value for AL is 0F5H. With the instruction add, it tells you to add 0F5 with 0BH. So the solution is we add F5 plus 0B equals to 100. In binary form, F5 is 11110101 plus with 0B, which is 00001011. So we add it like always. So for the flag settings, after the addition, the AL register destination contains 00 and the flags are as follows. The carry flag is 1 since there is a carry out from D7. The sign flag is 0 because the status of D7 of the result is 0. The parity flag equals to 1 because the number of 1 is 0 and 0 is an even number. In the result, there is no number 1s. So when there is no, it means 0. So 0 an even number. That's why the parity flag for even is 1. The auxiliary flag is 1 because there is a carry from D3 to D4. And lastly, 0 flag equals to 1 because the result of the action is 0. For the means because the result is all 0, so the 0 flag equals to 1. Subtraction of unsigned numbers. In subtraction, x86 processors use 2's complement. Internal adder circuitry perform the subtraction command. X86 steps in executing the sub instruction. The first step, take 2's complement of the subtrahend source operand. Second step, add it to the minuend destination operand. And the last step, invert the carry. These steps are performed for every sub instruction regardless of source and destination of the operand. Below are the subtraction form. After the execution, if carry flag equals to 0, the result is positive. If carry flag equals to 1, the result is negative and the destination has the 2's complement of the result. For example, show the step involved in the following. They give you AL3F, BH23H, and instruction sub ALBH, which means the value data for AL is 3F, and they give you the value data for BH is 3. Then the instruction gives you to sub AL and BH, means you must subtract BH from AL. And lastly, place result in AL. So the solution is the 3F minus with 2 3, we will get 1CH. In binary form, 3F is 00111111 and 23 is 00100011. We need to use 2 complement. So from the 2 use the 2 complement, it will become 1101 1100. After we use 2 complement, we must add with 1 and the result will become 1101 1101. And after that, lastly we can add it with the new complements. And the result you will get 100011100 and the carry flag is 0. For the flag setting, the flag will be set as follows. Carry flag equals to 0, zero flag equals to 0, auxiliary flag equals to 0, parity flag equals to 0, and SF equals to 0. The programmer must look at the carry flag, not the sign flag, to determine if the result is positive or negative. For your information, the actual calculation, the result, we will get the carry flag equals to 1 because a carry from D7 to D8. But the step for subtraction instruction, the last step, you must take note that we must invert the carry. So that's why the final answer, the carry flag equals to 0. So when we know the carry flag equals to 0, we know that the result is positive. Alright, move on to the second topic, which is code assembly language logic instructions. There are many logic instructions, like for example, compare, CMP. There is also rotate right, ROR, and rotate left, ROL. But I'm gonna cover for AND, OR, and XOR, shift right and shift left. For AND, the form AND instruction. This instruction will perform a logical AND on the operands and place the result in the destination. Destination operand can be a register or in a memory. Source operand can be a register, memory, or immediate. And will automatically change the CF and OF to 0. PF, ZF, and SF are set according to the result. The rest of the flags are either undecided or unaffected. So for the logical AND function, we must multiply for the first input and second input to get the output. So 0 times 0, 0 times 1, 0, 1 times 0, 0, 1 times 1, 1. And can mask certain bits of the operand and also to test for a 0 operand. This code will AND DH with itself and set ZF equals to 1 if the result is 0. For example, show the result of the following. They give you BL35H and in AND instruction BL0FH. So it means that the data value for BL is 35. So the instruction wants you to AND BL, which is 35, with 0F. So AND BL with 0F, place the result. So the solution will be, you write the 35 and 0F. So to get the answer, you expand it in binary form. So 35 is 0011 0101 and 0F is 00001111. So we AND it, the first 35 and the OF. So 1 times 1, 1, 0 times 1, 0, 1 times 1, 1, 0 times 1, 0, and so on. So for the flag setting will be SF equals to 0, ZF equals to 0, PF equals to 1, and CF and OF will reset to 0. SF equals to 0 because the result of D7 status is 0. The ZF equals to 0 because not all the result is 0. Equals to 1 because if we look, there is 1, 2. Two number of 1 means even. And when even, the parity flag equals to 1. OR. This is the form of OR instruction. Destination or source operands are ORed. Result placed in the destination can set certain bits of an operand to 1. Destination operand can be a register or in memory. Source operand can be registered in memory or immediate. Flags are set the same as for the AND instruction. CF and OF will be reset to 0. SF, ZF, and PF will be set according to the result. All other flags are not affected. So for the logical OR function, we must add both inputs to get the output. The OR instruction can also be used to test for 0 operand. OR BL0 will OR the BL with 0 and make ZF equals to 1 if BL is 0. Or BL will achieve the same result. For example, show the result of the following. They give you AX0504 and OR AX0DA68. So means here, the value data for AX is 0504. So they give you instruction. They want you to OR AX, which is 0504, with 0DA68 and prove it. How does it get DF666C? Sorry. So the solution, the same like AND, but we must, but for the OR function, we will use addition. So 0504, 000, 0101, 0000, 0100. For DA68, 1101, 1010, 0110, 1000. So this both input, both data value, we will OR it and we will get 0 plus 0, 0, 0 plus 0, 0, 1 plus 0, 1, 0 plus 1, 1, 0 plus 0, 0, 0, 1, 0 plus 1, 1, 0 plus 1, 1, 0 plus 0, 0, and so on. And the final result, you will get DF6C. So the flag setting will be SF equals to 1, ZF equals to 0, PF equals to 1, CF and OF will reset to 0. Notice that parity is checked for the lower 8 bits only. Alright, so for the SF, we will look at the D15 status. So the is equal to 0 because the result is not all 0. For the parity flag equals to 1, as they noted here, the parity is checked for the lower 8 bits only. So we look at the lower 8 bit. So the lower 8 bit has 1, 2, 3, 4. 4 numbers of 1 means it is even. So when it is even, the parity flag equals to 1. Next one is XOR. This is the XOR form instruction. XOR will exclusive OR operands and place result in the destination. Set the result bits to 1 if they are not equal, otherwise reset to 0. Flags are set the same as for AND. Operand rules are the same as in the AND and OR instructions. So for the logical XOR function, we must add both input to get the result output. But if both input have the same value, for example here 0, 0, the result will become 0. Second example, if input is 1, 1, the result is 0. For example, show the result of the following. They give you DH54H and XOR DH78H, which is mean that the value data for DH is 54. So the instruction they give you is XOR 54 with 78. So the solution here, when you expand in binary form, 54 is 0101, 0100. 78 is 0111, 1000. So when we XOR, 00 is 0, 000, 101, 011, and so on. For the flag setting, will be SF equals to 0, ZF equals to 0, PF equals to 0, and CF and OF is same like AND and OR instruction. It will reset to 0. So equals to 0 because the D7 result status is 0. ZF equals to 0 because the result is not all 0. The parity flag equals to 0 because if we look the result here, we have 1, 2, 3. 3 number of 1 means it is odd. When odd, PF equals to 0. Alright, let's go to shift. Shift the content of a register or memory location, right or left. There are two kinds of shift. The first one is logical for unsigned operand, and the second one is arithmetic for signed operand. The number of times or bits the operand is shifted can be specified directly if it is once only, through the CL register if it is more than once. Shift right. SHR, logical shift right. Operand is shifted right bit by bit. For every shift, the LSB, least significant bit, will go to the carry flag, CF. The MSB, most significant bit, is filled with 0. For example here, show the result of shift right in the following. They give you AL9AH, CL3, and the instruction shift to the right, ALCL. What they means here is you must use the data AL9A and shift to the right 3 times. Since they give you CL3 means you need to shift it 3 times. So the solution here is when we expand the 9AH into binary form, we will get 1001, 1010. So we shift to the right bit by bit. Note that the end of the right is LSB and the end of the left is called MSB. Like I have note it here, up here, the LSB and MSB. So for example this, so we shift the 0 to CF and then we shift bit by bit to the right. So here will become 1011 1010. So for the MSB, insert the 0 into MSB every time you shift to the right. So shifted twice, you will take this one to the carry flag and then you will shift bit by bit for every bit hit in there, and the last bit set 0 into MSB. Same goes when you shift it 3 times, you will take this 0 to CF carry flag and then you shift it bit by bit to the right and you will insert 0 into MSB. So after shifting right 3 times, you will get L equals to 13H and CF equals to 0. For the shift left, SHL, logical shift left, is the reverse of shift right. After every shift, the LSB is filled with 0 and MSB goes to carry flag. So all rules are the same for shift right. Alright, so note that this MSB and LSB up here. We look at the example, show the effect of shift left in the following. So they give you DH6 and CL4. So the instruction they give you to shift to the left the 6 4 times. So you need to shift 6 4 times. So the solution, you will expand the 6, you will get 0 0 0 0 0 1 1 0. Alright, so if you want to shift to the left, you take the 0 at MSB here and take it as the first carry flag, and after that you shift bit by bit to the left and you insert the 0 at LSB. So you repeat the ways until you shift for the 4 times, where 0 you will insert into carry flag, and then you will shift to the left bit by bit, and then you will insert the 0 into LSB. So after the 4 shift left, the DH register has 60H and CF equals to 0. Alright guys, we almost come to the end. So let's do some exercise to make you better in understanding the instruction. For the question 1, they give you BH3FH and add BH45H, which means here is the value data for BH is 3F. So the instruction wants you to add 3F with 45. You 30 seconds for you to complete the question. Alright, time's up. Let's check the answer. So you add 3F with 45, you will get 84. So in binary form, 3F is 01111111 plus with 010101. So when you add it, you will get this answer. So the BH result is 84. For the carry flag is 0 because there are no carry in D7 to D8. The 0 flag equals to 0 because the result is not all 0. And the auxiliary flag equals to 1 because there is carry between D3 and D4. Okay, for the second question is the subtraction. They give you 2 3H, subtract 1 2H. So I'll give you 30 seconds to solve the problem. Okay, time's up. So for the solution, the second question, so 2 3 minus 1 2, you will get 1 1H. So you get the answer 1 1H. But to determine whether this result is positive or negative, so 2 3 is 0 0 1 0 0 0 1 1. 1 2 is 0 0 0 1 0 0 1 0. So remember the step for subtraction. You must use to complement to get the result. So you complement the 1 2, it will become 1 1 1 0 1 1 0 1. After you complement it, you must add with 1 to get the result 1 1 1 0 1 1 1 0. And the final result is you add 2 3 0 0 1 0 0 0 1 1 with the new 1 2 that you have complement here, and you will get this answer. So the carry flag you get is 1 because there is carry between D7 and D8. But remember the step 3 for subtraction. Step 3, following operations indicate the result and the register where it is stored. Give also ZF and CF in each case. Alright, for the question number 3, the instruction is you must AND DX and AX. So we know here that DX is E390 and AX is F000. So it is a 16-bit. I'll give you 30 seconds to try complete the question. Alright, time's up. Let's check the answer. So here, E390 is 1110001110010000, and F000 is 1111 and 00000 until the end. So we end it. Remember, if end instruction you means here, you must OR DH and BL. But the question, they didn't give you DH and BL. So how do you find DH and BL? Actually guys, DH can be found from the DX and BL can be found from the BX. So for the DH, from the DX, we will take E3 as DH, and from the BX, they want BL, so we will take 5. So if the question asks you for DL, then you will take 90. If the question asks you for BH, then you will take 34. So these two data, you OR it and tell me what you get. I'll give you 30 seconds to complete the question. Okay, time's up. Let's check the answer here. So E3 is 11100011 and 56 is 01010110. So we OR these two data, and so remember when OR we will add these two. So 1 plus 0, 1, 1 plus 1, 1, 0 plus 1, 1, 0 plus 0, 0, and so on until you get the result. So goes to 0. Alright, for the fifth question, XOR AL76. So how can you get AL? So you can get AL from the AX. So the AL is 0, 0. So XOR 0, 0 with 76. I'll give you 30 seconds to complete the question. Okay, time's up. Let's check the answer. So 0, 0 is obviously 0, 0, 0, 0, 0, 0, 0. And 76 is 01110110. Okay, so the instruction asks you to XOR means you have to exclusive OR these two data and you will get the result. Remember, XOR means if both data is the same value, then the result will be 0. If the both data is different value, the result become 1. So for the result and the register where it is stored, AL equals to 76, CF equals to 0, and ZF equals to 0. So always remember, for AND, OR, and XOR, the CF and OF will reset to 0. As for the ZF, remember, if the result is not all 0, then the ZF equals to 0. Alright, for the sixth question, the last two questions before we finish. To the right, DX1 means here you must shift to the right E390 for 1 times only. So I'll give you 30 questions to try solve the question. Okay, time's up. Let's check the answer. So E390 is 1110, 0011, 1001, 0000. So you shift to the right one time. So 0 in the LSB, you will take it to the CF, and then you shift to the right bit by bit here, and you will insert the 0 to the MSB. So the final, you will get dx equals to 7168, CF equals to 0, and ZF equals to 0. For the last question, move CL04, shift to the left, AL, CL. So remember, CL indicate that you must shift to the left 4 times. And AL, where do you get it? You will get AL from AX. So the AL is 0, 0. I give you 30 seconds to solve the question. Okay, time's up. Let's check the answer. Okay, so 0, 0 in the binary form is 0, 0, 0, 0, 0, 0, 0, 0. So the last one is pretty easy. So you just shift the 0 at MSB here into CF, and then you shift to the left bit by bit, and then you insert the 0 into LSB. You repeat the steps for 4 times, as the question wants you to shift 4 times. And the result, you will get AL equals to 0, 0, CF equals to 0, ZF equals to 1. Alright, for shift, how do you get carry flag? You will look at the final carry flag you get here. And as for the ZF, it's the same as previous. Look at the result. If the result is not all zeros, then the ZF equals to 0. For the question number 7, the result is all 0. So when the result is all 0, ZF equals to 1. Alright guys, thank you very much for listening and watching my video. So always note that the instruction, there are 2 type of instruction, which are arithmetic and logic. So take note also the flag setting and the rule that apply on each instruction and how to execute it. It's pretty tricky, but I believe we can do it if you do more exercise. So that's all from me. Thank you.